Hey everyone, back with you. Today we're going to talk about Pythagorean theorem. Pythagorean theorem. So a theorem, in case you're wondering, it's kind of like a law in science. It's something that's been proven to work. And so the Pythagorean theorem was proven by this guy named Pythagoras that you should have learned about in Mr. Fox's class last year. Who was a scholar, a Greek scholar who learned a lot of things, but probably his most famous is this thing about right triangles. So the first thing that's really important for you guys to remember is that when we're talking about Pythagorean theorem, it only works for right triangles. You can't just use it for any triangle you see or for a square, particularly right triangles. If we were going to take our state test this year, I would show you a lot of tricky problems where it looks like it's not a right triangle. There's a right triangle hidden somewhere in the problem that they're trying to trick you about. And in particular, you're looking for just where is the right triangle, because it's probably Pythagorean theorem. So goals today, I want to get through what does it look like and a couple examples. And then at the end of this video, I'm going to put two problems on my whiteboard that I want you guys to answer and submit through Google Classroom. Just try it out. All right, so first of all, if we are using Pythagorean theorem, what it does is it allows me to find the missing side of a right triangle. All right, so if I knew two sides of a triangle, in particular, let's say I know this side is 3 inches and this side is 4 inches. Okay? Imagine if I was building, obviously this is small because we're talking inches, but like the scale of a roof. I'm making like a little fort, a little model of a roof, and I want this height to be 3 and this length to be 4. I want to know how long does this side need to be if I want to find that. So Pythagorean theorem can help us to find a missing side, any of these sides if they're missing, as long as we know two of them. So the theorem, you may have heard this before. In fact, it's like I said, it's pretty famous. The theorem says Pythagorean theorem is a squared plus b squared equals c squared. All right, those are exponents. So a squared plus b squared equals c squared. The a and the b, and this is very, very important, are the legs of the right triangle. If you don't remember that from yesterday, the legs are the side that make this right angle up. So it doesn't matter what order they're going to go in, the 3 and the 4. All that really matters is that they go somewhere either for A or B. You can put the 4 first, you can put the 3 first. You'll get the exact same answer. It does not matter. But those two sides are legs. They have to go in for A and B. So if you haven't already guessed then, that would make C the hypotenuse. All right, the hypotenuse, the longest side, has to always go where the C is. And as long as you do that, you follow those rules, the math behind this thing is pretty easy. So the legs are always going to be A and B. The hypotenuse is always going to be C. So let's say I had this triangle. I know that 3 is a leg, 4 is a leg. That means this side must be C because it's my hypotenuse. Remember, if you're not sure, it's the one that's across from the right angle is always the hypotenuse. So if I wanted to use this formula to find the missing side, I am going to make this side, we'll say, is A. So A squared plus B squared equals, we don't know what C is, so we're just going to leave it C squared. Just like so. Okay? Now, as you can probably imagine, we're just going to kind of do some order of operations stuff here. So we need to make sure we do these exponents first. So 3 to the second power, 3 times 3 is 9. 4 to the second power is 16. We have no idea what c is still, so we're just going to leave it c squared. Now, as you can see on this side, we have some like terms. 9 and 16, we can just add those together. That's 25 equals c squared. And this last step is going to take us all the way back to September, which, I don't know about you guys, seems like 5 school years ago. So there's probably a pretty good chance you're not going to remember this. But if you remember, how do we get rid of something that's squared? What's the opposite of an exponent here? And hopefully you guys can remember, if we want to get rid of something squared, we need a square root. Roots and exponents are opposite. So this step is always going to happen in Pythagorean theorem. At the end here, we're always going to need to get rid of some exponent, so we're going to have to use some root. So I'm going to square root this side, which means whatever I do to one side, I have to do the other. And I'm going to square root this side. So the square root and the squared, they cancel each other out. We're just going to have c. And hopefully you're all at home saying, oh, square root of 25 is 5 and -5, which is excellent if you remember there's 2 answers. But since we're talking about a distance, we're only going to use that positive number, because there's no such thing as a negative distance of a triangle, right? So for our answer here, we only need 5 inches. Now, if you remember when we did square roots are the largest group of irrational numbers. So a lot of times this might not turn out very pretty, right? So you can round your answers to the hundredths. We'll just use decimals, or you can leave it in square root form. So for example, if this was square root of 30, that'd be an okay answer. Or you could take the square root of 30 and see that it's 5.12 or whatever it is, right? I'm trying to use pretty examples because I don't have my calculator like sitting here like I would in class. And so I'm trying to just do ones off the top of the head and I'm going to remember what they are. But yours could totally be irrational numbers. You're just going to have to round them to the hundredths place. All right? So that's an example for one if we're looking for the hypotenuse. What if I was looking for a leg? That's going to look a little bit different. All right, 3 minutes. I'm trying to keep these videos to about 10 minutes. So we'll see how I do here because I have a lot to do. All right, let's try one. Let's say I have this triangle. It's a right angle. And I know that this side over here is 10 feet. And I know that this side over here is 6 feet. All right, still a right triangle. So when I see right triangles, I think Pythagorean theorem. It's one of the first things I think about. And we can see that this time, the side across from the right angle, the hypotenuse, we know that. So 10 needs to go in for c in this equation. That is the most important thing that you have to realize. Every time, check the hypotenuse, that number has to go for c. The legs are a and b, doesn't matter what order, we said that already. So in this case, we know that c here is going to be 10. That means that 6 is either going to be a or b. It does not matter. So I'm just going to make this side a for fun. It's so fun. So we'll say that we have a squared plus, this is going to be 6 squared, equals, this is going to be 10 squared. So this one is going to look a little different than the last one we did, but all of them, there's only 2 things that can happen. You're missing a hypotenuse or you're missing a leg. So every example that you do is going to look either like the first one or this one. So, same thing. We're going to go ahead and use our exponents first. So we don't know what a is. 6 times 6 is 36. 10 times 10 is 100. Now this time, I want to get a by itself. There's another number on this side. So it's kind of like 2-step equations. Remember when I told you guys, back when I actually was your teacher, like eons ago, that everything always comes back to some idea of a 2-step equation. This is no what's that word? Substitute? You know,
Exception.
no exception. That's it. No exception. So, if I want to get a by itself, we got to get rid of this plus 36. So we're going to subtract 36 to both sides. Every time you're looking for a leg, you're going to have some step right here where you're going to subtract something from one to the other. That gives me a squared equals 64. And then, just like I told you on the last one, there's always going to be something that happens where we're going to have to get rid of a root or an exponent. So if I want to get rid of the squared, I need a root. I need a square root. So I square root both sides, and that's going to give me a equals square root of 64. We only need the positive version of 8 feet. So this side of my right triangle is 8. Okay? So that is 2 examples. I told you guys I'd give you 2 that I want you to try. I was going to say, did you all see this in time? But you can literally pause this video, right? It's weird. Much different than real life. So, the 2 I want you guys to try on Google Classroom. I'm going to try to give you a pretty one and a not pretty one. And we'll see how that goes. So we'll call this one problem 1. Call this one problem 2. Problem 1, I'm going to tell you this side over here is 13 meters. And we'll say this side is 12 meters. And then on number 2, so this is the side we don't know. And then on number 2, I'll say that this side over here is 16 yards. And this side over here is 19 yards. So I want you guys to try both of those. Try to type your work. Ooh, I'm getting fuzzy. Try to type your work in on Google Classroom if you can. Or if it makes more sense, you can write it on a piece of paper and then take a picture, scan it in, and you can share the scan with me, okay? Tomorrow, we're not gonna have a video. I'm gonna give you guys the Math XL and a couple examples from our book for you guys to do. And then we're gonna talk about the converse of the Pythagorean theorem on Thursday. All right, peace out, y'all.